Now we can finally start training our model. One quick step before training your model is splitting your dataset. You need to randomly split the dataset, keeping some of the data hidden from training. This enables you to later evaluate your model with the data before it's put into production. A training dataset is the data that will be used when your model is training. Most of your data will be here. A general rule of thumb is around 80% of your data. There's also a test dataset. This is the data that the model hasn't seen during training. It's used during the model evaluation stage. It helps you see how well your model will generalize to new data. As you learn more about machine learning, there are additional components, such as validation data. Those are outside the scope of this lesson, but just keep them in mind. What exactly is model training? Let us start with a general definition. The model training algorithm iteratively updates the model parameters to minimize some loss function. Let's unpack that one. Model parameters are setting, knobs, or configurations that the training algorithm can update to change how the model behaves. Depending on context, you'll also hear other more specific terms used to describe model parameters, such as weights or biases. Taking a look at this snow cone example, since we were trying to fit a linear function to this data, the parameters would be the orientation and location of the line. Nearly all models are trained by slowly changing model parameters to move the model closer and closer to achieving some goal. A loss function is used to codify the model's distance from this goal. For example, if you were trying to predict number of snow cone sales based on the day's weather, you care about making predictions which are as accurate as possible. So you might define a loss function to be something like the average distance between your model's predicted number of snow cones sold and the actual number. Here is a concrete example. Imagine that your model predicts you would sell 12 snow cones on a day where the temperature is 95. Our historical data shows the number of snow cones sold is 15. The difference between 12 snow cones predicted and 15 actual snow cones sold, which is, as you can see, is 3, is what the loss function seeks to minimize. In practice, you will likely use one of several common loss functions for most problems. Of course, there are plenty of other details involved in the process. Let's touch on a few high-level questions you might have and a few useful things to know. As you grow your familiarity with this space, you will learn a few common model training algorithms. You could absolutely implement these from scratch, but unless you're developing brand new models or algorithms, you will likely use one of many machine learning frameworks which already have these implemented for you. Determining which model to use, a process known as model selection, is not a perfect science. The list of established models is constantly growing, and even seasoned machine learning practitioners will try many different types of models while solving a problem with machine learning. Within this course, you will see a few types of models at the end of this lesson while walking through some real-world example. Oftentimes, a model or a training algorithm will have settings called hyperparameters, which cannot be changed during model training. These settings can affect how quickly or how reliably the model trains. You will see this across many steps in this process, but be prepared to iterate. Pragmatic problem solving with machine learning is rarely an exact science. Often you might have assumptions about your data or assumptions about the problem which turn out not to be true. Don't get discouraged. Instead, foster a habit of trying new things and measure success in a way that lets you compare results across iterations.